In this video, let's practice using our knowledge of prime factorizations to write complete factor lists. Basically, the objective of these practice problems is for us to be able to create a list of all the possible factors of each of these given numbers. For the particular strategy that I'm using in this video, I'm assuming that you already know how to create prime factorizations. If you need a refresher on how to create prime factorizations, please check out one of my previous videos where I do so using factor trees. So for number one, if you were to take the number 12 and make a prime factorization tree, you should end up with a prime factorization of 2 times 2 times 3. Using these prime factors, we can go ahead and make a Using these prime factors, we should be able to come up with all the factors of 12. First of all, we know that 1 times 12 are going to be 2 factors of 12. Then we see this 2 on the list, so 2 multiplied by the rest of these, that's going to be 2 times 3 is 6. So we know that 2 times 6 is going to also equal 12. We can see also on this list that we have a 3, so 3 multiplied by the rest of these prime factors, or 2 times 2, which is 4. We can see that 3 times 4 does equal 12 as well. At this point, we have all the factors for 12. For number 2, for 15, the prime factorization would be 3 times 5. So if we were going to go ahead and write a factor list for 15, we would start off with 1 times 15, that's always a given. And then there's no 2 on the list, so we can skip that. But there is a 3, and 3 times 5 does equal 15, so we can put 3 and 5 as 2 more factors. There's no 4, and then 5 is going to be repeated, so we can stop right there. Those are all the factors for 15. For number 3, the prime factorization for 20 is going to be 2 multiplied by 2 multiplied by 5. Okay, so that's its prime factorization. For the factors of 20, we are definitely going to start with 1 times 20. Those are 2 factors of it. We also can see that there is a 2 on the list, so 2 multiplied by these together is going to be 10. So we know that 2 times 10 is also equal to 20. There's no 3 on the list, so we can skip that one. There is no visible 4, but keep in mind that you can create 4 by multiplying these two 2's together. So that's 4. 4 times this 5 will also equal 20. So that's going to be our last 2 factors of 20 here. For number 4, the prime factorization for 18 is going to be 2 times 3 times 3. So if we're going to go ahead and write the list of factors for 18, we're definitely going to start with 1 and 18. And we do see a 2 on this list, so 2 times the rest of these, that's 2 times 9. So 2 and 9 are also factors. There is a 3 on the list, so 3 over here multiplied by these 2, which makes 6, means that 3 times 6, those 2 are also going to be factors. There's no way to get 4 because you need 2 2's, and there's no 5 because 5 would be a prime number, so these are all the factors of 18. Let's check some more out. So if we look at number 5, we have the number 20 here. So the prime factors here are going to be 2 times 2 times 5. Just get some extra practice. I know some of these may be a little bit redundant after a while, but we have 1 and 20 are going to be the first 2. And then we have 2 times 10, right? 2 multiplied by 10 also gets us 20. And then we can see here that this is 4 from 2 times 2. So 4 times 5 also equals 20. So any combination of these prime factors will get us another factor. For number 6, the prime factorization for 27 is going to be 3 times 3 times 3. And so let's see what we have here. Well, first of all, we do have 1 and 27. Those are going to be 2 factors. We see a 3 here. 3 times these 3's make 9. So 3 times 9 is also 27. I think that's going to be it for this one though. Okay. For number 7, the prime factorization for 30 is going to be 2 times 3 times 5. Okay, so for the factors, we'll start with a 1 and 30, and we do see a 2 here, so 2 times these 2, so 3 times 5 is 15. So we know 2 times 15 does get you 30 as well. We do see a 3 here, so 3, and then if we combine this 2 and 5, 2 and 5 make 10. So we know that 3 times 10 also equals 30. And let's see what else we got here. There's no 4. We would need 2 2's to make 4, but I do see a 5. 5 times these 2 together, that's 6. So 5 times 6 are going to be 2 more factors of 30. Okay. For number 8, at the bottom here for 45, if we do the prime factorization, we should find that's 3 times 3 times 5. And so that's our prime factorization. We know 1 and 45 are going to be factors. There's no 2 here, so we don't have to worry about that, but 3 times these two, that's 3 times 15. That does get you 45. There's no 4, there is a 5 here, so 5 multiplied by these two together is 9. So 5 times 9 does get you 45 as well. There's no 6, we would need a 2 for that. 7's prime, 8 won't work, and 9 we already have. All right, so these are the first 8 here, and just keep in mind that if we were able to look at these, there's a pattern here. The reason why I'm writing this specific way is that you can see that if you go down this list, you actually get them in order from least to greatest, all the factors. So 1, 3, 5, 15 in order, 1, 2, 4, 5, 10, 20, all the factors from least to greatest in this pattern, right? So we have this 1, 2, 3, 6, 9, 18. Those are the 6 factors. 1, 2, 4, 5, 10, 20 in order. There's only 4 factors here for this 27. If we look at number 7 here, there are 8 factors coming around the bend here, all in order from least to greatest. All right, so hopefully that helps you keep them organized as well. If we look at number 9, we have the number 11 here, so that's actually a prime number, so its prime factorization is just 11. So its prime factorization helps us know that it's just going to be 1 and 11. So remember, prime numbers only have 2 factors, 1 and itself. For number 10, we have the number 28. So that's going to break down into 2 times 2 times 7. And so for the factors here, we definitely have 1 and 28. We see a 2 here, so 2 times whatever these make, which makes 14. So that's going to be 2 and 14 are also factors of 28. There's no 3 on here, but there is a 4 from these two 2's make 4. 4 times 7 is going to be 28. The only numbers left between 4 and 7 are 5 and 6, and they can't be on the list here. So for this one, we had our 2 factors, 1 and 11. Here we had 6 factors, 1, 2, 4, 7, and 28 for the number 28. These are the only numbers you can split 28 into evenly with no fractions or decimals. For 11, the prime factorization of 35 is, for number 11, the prime factorization for 35 is just going to break down into 5 times 7. So we know we have the factors of 35 are going to be 1 and 35 to start. There's no 2 or 3 or 4. There's no way to get those, but there is a 5, so 5 times 7. So this one is a short list. It's just going to be 5 and 7 to complete it. So we have these 4 factors, 1, 5, 7, and 35. For number 12, we have this number 48. So 48 breaks down into, let's see, 2 times 2 times 2 times 2 times 3. That would be the prime factorization for 48. So starting off, we know we have 1 and 48, just like usual. We do have a 2 on here, so 2 times the rest of these. But let's see, 2 times 2 is 4, times 2 is 8, times 3 is 24. Hopefully that makes sense. 2 times 24 is 48. There is a 3 on the list, so here's 3. So let's multiply the rest of these together here. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So it turns out that 3 times 16 is also 48. Is there a 4 on the list? We don't see a 4, but remember, we can combine 2 2's to make 4, and then we can combine these 3 numbers. So 2 times 2 is 4, and 4 times 3 is 12. So it looks like 4 times 12 will also equal 48. There's no 5 on the list, which was prime, so that's not there. There's no visible 6, but keep in mind you can make 6 from these 2 numbers. 2 times 3 is 6. So let's multiply the rest of these. 2 times 2 is 4, times 2 is 8. So we have 6 times 8, and that also equals 48. We know we can stop here because the only numbers left between 6 and 8 is 7, and 7's prime, and it's not on the list. So, and there's no way to make 7 because it's a prime number. So these would be the 10 factors for the number 48. If we keep on going down to try a few more, for number 13, looks like we have the number 36. So 36 is going to be 2 times 2 times 3 times 3. And so for 36, we definitely have 1 and 36. I see 2 here, and combine these. So 2 times 3 is 6, and 6 times 3 is 18. So that's going to be 2 and 18. I do see a 3 on the list, and combine the rest of these. So 2 times 2 is 4, and 4 times 3 is 12. So it looks like 3 times 12 also gets you 36. Do we see a 4 on the list? Not visibly, but 2 times 2 does get you 4. 3 times 3 gets you 9. So 4 times 9 gets you 36. There's no 5. Can we make 6? I think so. So 2 and 3 make 6, and 2 and 3 also make 6. So hopefully it makes sense that 6 times 6 is 36. Now, if you're going to say, like, how many factors does this have? Don't go ahead and say that there are 10. There's actually 9. And that's always going to happen to be the case where you have an odd number of factors if you have a perfect square. So only count one of these 6's once. So I'm going to go ahead and put an X through one of these 6's. So you don't accidentally say that there are 10 factors. There are 9 factors. For number 14, we have the number 24 that breaks down into 2 times 2 times 2 times 3. And so we have 1 times 24 to start. And let's see, there is a 2 on this list, so 2 times the rest of these. 2 times 2 is 4, 4 times 3 is 12. So we have 2 times 12 is also 24. We see a 3 on the list and combine these two, so 2 times 2 is 4, 4 times 2 is 8. So we know 3 times 8 also gets you 24. I don't visibly see a 4, but keep in mind 2 2's do make 4 if you multiply them, and 2 and 3 make 6. So 4 times 6 also equals 24. The only numbers between 4 and 6 is 5, but 5 is a prime number and it's not on the prime factorization, so that's why it's not divisible by 5. For number 15, the number 32 breaks into 2 times 2 times 2 times 2 times 2. Alrighty, so prime factorization helps us out here. The factors of 32 we're going to start with are going to be 1 and 32. That's kind of a given. Then 2 multiplied by the rest of these. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that's going to be 2 times 16. That's 2 more factors. There's no 3, so let's go to 4. 2 times 2 is 4. Then the rest of these, 2 times 2 is 4, 4 times 2 is 8. So we have 4 times 8 also gets you 32. There's no 5 on the list. There's no 6. 6 needs to have a 3 in there, so there's no 3, so there's no 6. And there's no 7. 7's prime. So 32 has 6 factors. 1, 2, 4, 8, 16, and 32. For number 16, we have the number 72. 72 breaks into 2 times 2 times 2 times 3 times 3. Alrighty, so if we were going to go ahead and use those, the factors for 72, I'm going to go ahead and start with 1 and 72. Alrighty, we do see a 2 here, so 2 times the rest of these. 2 times 2 is 4, times 3 is 12, times 3 is 36. So we have 2 and 36 as another pair of factors. There's a 3 on the list, so 3 times the rest of these. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. So we know 3 and 24 are also 2 more factors. There is no visible 4, but keep in mind we can make 4 with these two 2's. And then 2, 3, 3. So 2, 3 makes 6. 6 times 3 is 18. So 4 times 18, those are 2 factors a lot of people miss for 72. There's no 5 because 5 would be on the prime factorization if it was. There is a 6 technically, right? Because 2 times 3 makes 6. And then we have to combine the rest of these, this 2 and this 3 and this 2. So 2 times 2 is 4, 4 times 3 is 12. So 6 times 12 will equal 72. There's no 7, there's no visible 8, but remember 8 comes from 2, 2, and 2. So 2 times 2 is 4, 4 times 2 is 8. So 8 times this 9 from the 3 times 3. 8 times 9 is also 72. So 72 has a lot of factors. It has all of these pairs. So it looks like it has a total of 12 different factors. Alrighty, so that's the first 16 here. Let's go on to number 17. For number 17, we have the number 49 to start with. The prime factorization is just 7 times 7. Factors to start with are going to be 1 and 49. And then we just have 7 times 7. I think that's it. So this one actually has a total of 3 factors, right? If you're going to say it's 4, just keep in mind that you don't count the 7 twice. So it's got 3 factors. For 18, you want to check your divisibility rules if you think it's prime. 5 plus 1 is 6, so it is divisible by 3. If you go ahead and divide, you should get 3 times 17 equals 51. So for its factor list, we definitely have 1 times 51 or 1 and 51, but then we have 3 and 17, which are both prime. And so we have 3 and 17 as our other two factors. So 51 has 4 factors. For number 19, we have the number 47, and 47 is actually just a prime number. So the only factors of 47 are going to be 1 and 47. 2 factors, which defines it as a prime number. For number 20, we have 60, so that actually breaks into 2 times 2 times 3 times 5. And so for 60, let's going to start with 1 and 60. I do see a 2 here, so 2 times 3 is 6, and 6 times 5 is 30. Hopefully that makes sense. 2 times 30 does equal 60. Is there a 3 here? There is a 3. So the rest of the numbers are 2, 5, and 2. So 2 times 5 is 10, 10 times 2 is 20. So 3 times 20 also gets you 60. Is there a 4? Not visibly, but this 2 times 2 does get you 4. 3 times 5 is 15. So we have 4 and 15. That also gets us 60. Is there a 5 on the list? Yep, that's 5. And so combine these three. 2 times 2 is 4. 4 times 3 is 12. So 5 times 12 equals 60. Is there a 6? Well, let's see. Oh, 2 times 3 is 6. So 2 times 5 is 10. So 6 times 10 gets you 60. There's no 7, which is prime. To get 8, you need to have 3 2s, but we only have 2 2s. And to get 9, you'd have to have 2 3s, but we only have 1 3. So I think we are done. And we have a list of 12 factors here for the number 60. Moving on down, let's see what else we got here to try. For number 21, we have the number 80. So 80 breaks into 2 times 2 times 2 times 2 times 5. Alrighty, and so if we're going to write the prime factorization out, that should help us. We have 1 and 80 as our first 2 factors. 2 times the rest of these. 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. So we have 2 and 40. There's no 3 on the list, so we can skip 3. We can make 4 with these 2 2s. Then the rest of these, 2 times 2 is 4. 4 times 5 is 20. So 4 times 20 is also going to equal 80. There is a 5 on this list, so 5 is going to multiply by the rest of these. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we know 5 times 16 is 80. There's no 6 because 6 requires a 3. We don't have that. 7's prime, it's not on the list. 8 we can make here because 3 2s make 8. So 8 times 2 times 5 is 10. So 8 times 10 is 80. We can skip 9 just because you need 3s and we have no 3s to make 9, so it's not divisible by 9. We have 10 factors for the number 80. For 22, we have the number 75, and 75 breaks down into 3 times 5 times 5. And so for 75, we'll start with the factors 1 and 75. There's no 2 on the list, so we'll skip it. There is a 3, and then 5 and 5 make 25. So 3 times 25 gets you 75. There's no 4. There is a 5 though. So here's 5, and then 3 times 5 makes 15. So 5 times 15 does get you 75. 6 doesn't work because you need a 2. 7 doesn't work because it's prime and it's not on the list. 8 requires 2s, 9 requires 2 3s, we only have 1. 10 requires a 2 because it's an even number, and so you can keep looking, but I'll tell you right now that there are only 6 factors for the number 75. For number 23, we have 100, which actually breaks down into 2 times 2 times 5 times 5. And so let's start with 1 and 100, okay? Then 2, and then the rest of these, 2 times 5 is 10, 10 times 5 is 50, 2 times 50 also gets you 100. There's no 3, there is a 4, so here's 4, 4 times what? 4 times 25 gets you 100. No 6, no 7, no 8. I skipped 5 though by accident, oopsies. So here's 5, multiplied by the rest of these, so 2 times 2 is 4, 4 times 5 is 20. So 5 times 20 gets you 100. There's no way to get 6 or 7 or 8 or 9 but we can get 10. 2 times 5 is 10, and 2 times 5 is 10, so that means 10 times 10 is 100. So for the number 100, it looks like, does it seem like we have 10 factors or 9? Keep in fact that 100 is a perfect square, which means it has those two 10s in there, so it actually has 9 factors instead of 10. For number 24, the 23's prime factorization is just 23. It happens to be a prime number. So 23 just has 2 factors, 1 and 23. That's it. For 25, let's start with this number 16. 16 actually breaks into 2, 2, 2, and 2. So 4 2's multiply to get 16. For factors, let's start with 1 and 16. We definitely have a 2 here. 2 times 2 is 4. 4 times 2 is 8. So 2 times 8 is 16. There's no 3, that's prime and it's not there. 2 times 2 is 4, 2 times 2 is 4, so 4 times 4 is 16. And I think that is it, just because there's no more numbers between 4 and 4. For 26, sometimes people think 39 is prime, but if you know your divisibility rules, then 3 plus 9 is 12, which is a multiple of 3. So you can divide this by 3, and it turns out 3 times 13 would be the prime factorization. So for factors of 39, we'd have 1 and 39, but then we'd have 3 times 13. That's going to join the list as well, but there's no other combination, so it just has 4 factors. So it's definitely not prime, but it doesn't have a long list of factors either. For 27, what we have here is 96. I think 96 will break into 2, 2, 2, 2, 2, and 3. So I think that 96 is probably going to have a lot of factors here based on its prime factorization. We do have 1 and 96 to start. I do see a 2 and then the rest of these. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. So 2 times 48 is equal to 96. I do see a 3 on the list, so there's the 3, then combine the rest of these. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we know 3 times 32 is also equal to 96. Now, is there 4 on the list? Sure there is. From these two 2's makes 4. And so let's see what the rest of these make. 2 times 2 is 4, times 2 is 8, times 3 is 24. So 4 times 24 equals 96. There's no 5. 5's prime, it would be there. There is no visible 6, but keep in mind 2 and 3 do make 6. And the rest of these combined, let's see, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it turns out that 6 times 16 also equals 96. So 6 and 16. There's no 7. 7's prime, so it would be there, but it's not. 8. 8 comes from 2, 2, and 2, so there's an 8 here. And let's see, 2, 2 makes 4. 4 times 3 is 12, so it looks like 8 times 12 is also 96. Let's go ahead and put 8 and 12. 9 requires 2 3's, but we only have 1. 10 requires a 5. There's no 5. And 11's prime, so I think that's it. So it looks like we have 12 factors for the number 96. Let's check out a few more here. For 28, we have the number 120. So let's see if we can break this down. I think there's going to be a 2, and then a 2, and then a 2, and then a 3, and then a 5. I think that's its prime factorization. We'll start off with our usual 1 and 120. There is a 2 here. 2 and 2 make 4, times 3 is 12, times 5 is 60. So we're going to have 2 times 60. There is a 3 here, so that means we can combine these to make 10, times 2 is 20, times 2 is 40. So 3 times 40 also equals 120. Is there a 4? Sure there is. 2 times 2 makes 4, then 2 and 3 makes 6. 6 times 5 is 30. So it turns out 4 times 30 also equals 120. What about 5? Yes, 5's here. Combine the rest of these. So 2 times 2 is 4, times 2 is 8, times 3 is 24. So 5 times 24 are going to be 2 more factors. Is there a 6? Yes. 2 and 3 make 6. So 2 and 5 make 10 times 2 is 20. So 6 times 20 also equals 120. Let's see, 7 is prime, it's not on the list. Is there an 8? Yes, because 2 and 2 makes 8. 3 times 5 is 15, so 8 times 15 is also 120. Now for 9, we need 2 3s, but we only have 1. For 10, we can make 10. 2 and 5 make 10. And so if we take a look at the last few numbers here, so 2 and 2 make 4. 4 times 3 is 12. 10 times 12 is 120. 10 times 12. The only number between 10 and 12 is 11, and 11's prime, and it's not on the list. So look at all these factors for the number 120. We have 2, 4, 6, 8, 10, 12, 14. We have 16 different factors for the number 120. I think that's it's got the lead right now. For number 29, we have the number 144, which should break into 2 times 2 times 2 times 2 times 3 times 3, I believe. All right, to write out these factors here, let's start off with 1 and 144. I do see a 2 here, so here's the 2, and the rest of these 2 and 2 makes 4, times 2 is 8, times 3 is 24, times 3 is 72. So 2 times 72 also equals 144. I see a 3 here, so combine the rest of these. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48. So 3 times 48 also equals 144. There is a 4 here, so here's the 4, and then combine the rest of these. So 2 times 2 is 4, times 3 is 12, times 3 is 36. So we have 4 times 36. There's no 5. 5 is prime, it would be there, but it's not. For 6, we do have a 2 and a 3, which makes 6. The rest of these, let's combine them. So 2 and 3 make 6, times 2 is 12, times 2 is 24. So it looks like 6 times 24 also equals 144. There's no 7. 7's prime. There is an 8 though, because 2, 2, and 2 make 8. But then let's combine the rest of these. So 2 and 3 make 6, and 6 and 3 make 18. So it looks like 8 times 18 is equal to 144 as well. And if we take a look, there is a 9, because 3 times 3 makes 9. And so we can combine the rest of these. So 2 and 2 make 4. 4 and 2 make 8. 8 and 2 make 16. So it looks like 9 times 16 is also equal to 144. Let's see, 10 needs a 5, which we don't have. 11 is prime. 12. Oh, I think we can make 12, right? So 2 and 2 and 3 make 12. And so this 2 and 3 and 2 also makes 12. So I think that's 12 times 12 equals 144. Let's go ahead and put 12 times 12. And since they match, we are done, since there's no more numbers between 12 and 12. So right over here, it looks like we have 1, 2, 3, 4, 5, 6, 7, 8. 8 pairs, that's 16 factors, minus the 12s, that's 15 factors for the number 144. For number 30, we have the number 64. That breaks into 2 times 2 times 2 times 2 times 2 times 2. All right, let's see. I'm running out of space here. Let's see what we can do here. I do know we can start with 1 and 64. And I know we have a 2 here multiplied by the rest of these. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we have 2 times 32. There's no 3, but there's definitely a 4 here, times the rest of these. So 2 and 2 make 4, times 2 is 8, times 2 is 16. So we have 4 times 16. There's no 5, there's no 6, there's no 7, there is an 8. These make 8, so these make 8. So then we have 8 times 8, which is 64. So it looks like we have almost 8 factors. We really have 7 factors if we ignore one of these 8s. last couple here. For number 31, we have the number 77. 77's prime factorization is very short, thank goodness. It's just 7 times 11. So for the factors here, we're going to have 1 and 77 to start. And we really just have 7 and 11. That's the only combination here. So 7 times 11 does get you 77. And it's got a nice short factor list, 4 factors. Finally, for the number 32, we have 63, which breaks into 3 times 3 times 7. That's not too bad of a prime factorization. For its factors, we should start with 1 and 63. There's no 2 because 2's prime would be there. There is a 3, and combine these to make 21. So 3 times 21 does get you 63. There's no 4, there's no 5, there's no 6. There is a 7 here, 7 times these two, which makes 9. So 7 times 9 gets you 63 as well. So we have a complete list here of 6 total factors for the number 63. And that just about wraps up this video on 32 different practice problems where we worked on finding all the factors for each of the given numbers. And we did so by using a strategy of prime factorization. So if you already feel comfortable with finding prime factorizations using those factor trees or whatever method you like, that should make this process a lot easier to make sure you get all the factors without missing any. So hopefully you found this video helpful. And as always, keep with the great work, and I'll see you in the next one.